Hi everyone, this is Hussein from EJ Academy, and Amir is here with me today. How are you, Amir?
I'm good. How are you, Hussein?
I'm good, thank you so much.
Mm,
I have a problem. I need your help to solve this problem, and hopefully, the viewers watching this video they can learn something is helpful for them. Um, okay, let's get it started. So this is an application of derivative. It's an optimization problem. Assume we
mm,
have two numbers, let's call them x and y, and
mm,
we know the sum of these two numbers add up to 30, and we wanted to find this number such a way that the product of these two numbers becomes maximum.
mm.
So I wanted to see how you're going to solve this problem. So remember, you're going to use, this is the application of derivative. So you're
Derivatives.
going to use,
Mm.
derivative for this problem.
So what we want to maximize the product of those two numbers. So I guess I have to find
Exactly.
a function, which is the product of those two numbers. So okay,
Exactly.
as you said, we can call them those two numbers x and y.
Mhm. So these are our variables, basically.
Correct, because we don't know what the numbers are.
Right.
So the summation is 30.
Mhm.
And also uh, the product, we need to find a function for the product. So I call it f.
Mhm.
Uh, so f is the product of x times y.
Right.
And we have two variables. Using the second
Mhm.
equation, I'm going to find y in terms of x. So it's
Yeah,
going to
I,
be
I wanted
30.
to I wanted to
Huh?
actually I wanted to ask you, are these two variables independent? In other words, the
Yeah.
function f that you defined here, is that a function of x and y? These are two independent variable, or no, f is
No,
just dependent on one
yeah,
variable.
yeah. Since we have the first relation,
Mm-hmm.
that makes two numbers dependent on each other.
Exactly.
So because of that first relation, we can say that they are dependent, not independent. Otherwise, this f is like a surface, in 3 dimensions.
Right.
So uh,
So
because
here
of
you
the
define y in terms of x,
x, because I'm
using
gonna
the
get rid
given
of,
information.
yes, I'm gonna get rid of one of them. I
Mhm.
choose y, so I get rid of y.
Okay.
So because of that, I can have
You replace
this one.
y with the term that you found up there.
Correct. This is y.
Mhm. So,
Yeah,
so apparently, the way you defined it, f is a function of x.
correct. Yes.
Okay.
Now we can say, okay, this is product.
Mhm.
Now we can say, okay, the product is a function of x.
Correct. You're using distributive property here.
Yes.
Mhm.
And this is like a parabola, and we know
Yeah,
that,
it's a quadratic equation.
yes, we know that it's going to be something like that,
Exactly.
downward, because if you take derivatives two times, twice,
Mhm.
you get negative, so it's
Yeah.
downward.
Yeah.
Uh,
So usually quadratic equation is either concave down or up, but in this case, usually we look at the sign of x squared multiplier. If it's negative,
yes,
like we have here, it's concave down.
yeah,
Exactly. If it was
yes,
positive, it was concave up.
yes, exactly. And because f prime is like 30,
Hmm.
and then f double prime is -2, which is negative, so it
Right.
is downward,
Right. Yeah.
as I
The
showed
sign the
here.
sign of the second derivative shows if it's
Yeah,
concave down or concave up. Yeah. And
correct.
then these derivative that you wrote are with respect to
X.
variable x, right?
Correct. Yes.
Mhm.
Like this one.
Yeah. Thanks for the clarification.
And then, so we have this function 30x minus x squared, and we
Mhm.
want to maximize this one. So
Mhm.
the critical point is, at the maximum. So if we take a derivative, then we get the maximum
Okay.
value for that. So I'm gonna take the first derivative of f with respect to x.
Mhm.
So it's going to be df over dx, or f prime is equal to 30 minus 2x. And I'm gonna make it equal to 0.
Right.
That's the optimization problem. We take
Mhm.
the first derivative and we make it equal to 0.
Okay.
And depending on the critical number,
Mhm.
either it is maximum, absolute maximum, or absolute minimum, we maximize or minimize that function.
Okay.
So here we have 2x equals 30, and then x is 15.
In this case, we know it's a absolute maximum or absolute minimum. It's not
Yes.
local because it's a second degree
Oops,
or
sorry.
quadratic equation.
That's that's just jumped.
That's okay. So we know in
Yeah,
this case I was saying we know in this case it's not a local maximum. It's an absolute maximum because this is a quadratic equation.
correct.
Mhm.
So we obtained x, and then based on, let me call this equation number 1.
Mhm.
I call this number 2, and this one 3. So based on 1 and 3, I
Mhm.
have y equals 15 as well.
Okay.
Yeah. And okay, we know that these are the critical numbers. So if I put x inside this function,
Mhm.
I will get the maximum value for f, which is our
Okay.
product.
Okay. Or
So
simply we can multiply x by y, which is 15 by 15, right?
yes.
So it's going to be 225.
Yes, I
225
believe
is,
so. But
yeah, is the maximum.
yes, I can do that, or I can simply put inside this function, because
Mhm.
in terms of in the context of f of x, we can also do that.
Mhm.
So either the first approach, I call it approach A,
Mhm.
is like x times y, so 15 times 15 to 25, correct?
Yes.
And approach B, f of x equals 15. I'm gonna put it in this function.
Mhm.
So it's 30 times 15 minus 15 squared. So I can write it like this: 2 times 15, because this is 2 times 15. So it's 15 squared minus 15 squared. So it is 115 squared, correct?
Mhm.
Which is 225. So with both approaches, I get the same number. So yeah, uh, uh, so this value
Mhm.
is the answer to the question.
Yeah. So if, for example, you choose instead of 15 and 15, you choose I don't know, 14 and 16. Let me see. 14 and 16, if you multiply, it's going to be 224, less than the number that you got. And the goal in this problem was to find the
Yeah,
maximum, find
maximum,
the number such a way the product becomes maximum.
maximum. And the bottom line is that we try to find the function in terms of one variable, and then
Right.
we actually take the derivative of that function, making it equal to 0. We find the critical point of that, and then we have to verify if it is absolute maximum or absolute minimum, as we did here. So since it is absolute maximum, then with this number, we get, if we put that number inside this function, we get the maximum of this function.
Right.
So that's how it works. Yeah.
All right. Thanks, Amir. Thank you.
Sure, absolutely.
So for the viewers, if you have any questions about this problem, you can leave your question in the comment section below this video. And till next video, bye everyone. Thank you.
Thank you.